It's Labor Day. That's the one you threw out the bush. Yes. Did she not? She stayed in Central last year. I thought it was the same.
All right. So last time we were dealing with this concept that this is the case, and so I think, just to recap, I think what I'm going to end up doing is, so I'm broadcasting live on the video, so it's just coming off of that. I played with it, and you can actually see, as long as I don't write too small, you can see fine on the thing. So if you're sick, you got COVID, there's a couple people who sent me notices and stuff. If you do, you know, you can stay home, you're fine. I mean, I'm not going to ever, you'll never really need to hand me a sheet of paper for an assignment. It's all online, so, you know, do the best you can. And so did y'all get the email I sent? Okay. And so I did a kind of look back at the video. I did kind of a poor job of it, but I didn't want to redo it or edit it. Some people that you'll take, well, they'll make videos and they'll make a 20-minute video and spend 2 hours editing, and I'm too close to the end to worry about that kind of stuff. It just comes out naturally, or that's the way life is now. So I'm just going to take off and just go. Then there's going to be periods. What I'm going to do is try to load some stuff on my phone so that I can, you know, I used to project the problem onto the board, but if if this thing is having trouble and I'm projecting it, it's gonna have trouble there. So I'm gonna try to work out all the keys. So I'm going kind of old school. So we had this, and then before we had that, and we were doing the laws of sine and cosine. I think I wrote it on that side of the board. Laws of sine and cosine, and that got us through this. The next phase is, okay, I don't want to do law of cosine or sine. I want to do two vectors that are just straight up, you know. So I'm gonna, instead of doing that, I'm gonna do it both right down here. And I'm gonna say, here's B and here's A, and the thing is, it's just, okay, A vector is going to be the A value in the X direction times I plus the A value, and I wrote B, so, and then BXI plus BYJ. Now, often it's going to be laid up like it's an angle, so it might be an alpha, or let's just, you know what, I was talking about something last time. I think I'm going to re-talk about it, and that's the dot product, so if y'all don't mind, because the last lecture got kind of goofed up a little bit as far as the video. So if y'all don't mind, I might do that again for a second. But let's say this is 20 degrees, and let's say this is 30 degrees. And let's say the length of this thing is 10, the length of this thing is 20. It's obviously not to scale. Here, maybe I'll make it 12. Here, I'll make it 12, so it looks more to scale. So I'm going to add these two. So the way I do is I'll look at it right off, and I see, okay, and I'll go over this in a second. And again, you know, if you're comfortable with the adjacent, what's the opposite hypotenuse stuff, that's okay. That's okay to exist there. But the way I see things is I'm getting older, so I need to, if I have two things to remember, I'm going to throw away the one and try to remember in just one day. So, and it's not a bad idea. So if I look at AX, I'm looking at the X component, it's 20 degrees down, so cosine, it runs 20 degrees down, and I'm going to worry about the J in a second. And with the B, it's 30 degrees down. And it's of length 12. And then, in my mind, the other. Okay, now let me fill in the gaps by going over here, because maybe by the end of this class period, I'll be officially doing dot products anyway. So y'all have probably seen dot products somewhere. If I have two vectors, A, and I want to dot it with B, which is what I've got, A and B, then it's actually the magnitude of A times the magnitude of B times the cosine of the angle between them. And so what I'll do is, in math textbooks, they sometimes do like that, the angle between A and B. Now, let's say it doesn't really matter whether it's A or B or C or D or E. So I'm going to change this, since I already have an A and B, I'm going to change this to another one called C. And we'll see, so it's just some vector C. Now what I'm going to do is I'm going to draw the X and Y. Ooh, that kind of tilted, didn't it? So here's my X and my Y. I'm going to stick with my A, which runs out here, what does that say, 10, 20 degrees. So it's kind of really tilted down a little bit more. And it's 10 long. And now, this is my A. And what is my C? Well, I'm going to make my C this vector right here. And I'm going to say my C vector is actually the I vector. Okay, so now, okay, and I still have my 20 degrees. So now if I come down here, right underneath it, the dot product with A and C is equal to the magnitude of A, which in fact is the 10, the magnitude of C, which now, what's the magnitude of C? Anybody know what the magnitude of C is? 1. 1, exactly. So this is the key. The base vectors all have unit length. They're all supposed to have unit length. And if I didn't have unit length, then that would really mess things up, because I could say, go to the lunchroom, it's that far, it's like 30 yards over there. But then if I'm measuring it with a base vector of 2, then that's twice as far. So all these base vectors are direction vectors that have to be unit length. They always have to be. And you'll find in polar coordinates too, which we'll get to, that those are all base vectors of unit length. Every base vector is of unit length. So this is the mindset I have. And then the cosine is the angle between A and C, or 20. So if I dot, and here I'm just replacing it, 10 cosine of 20. So to me, okay, I see this as a projection. This is the way I see things. I might as well tell you that, because we're going to use dot products a lot later anyway. So if I'm projecting, it's the same thing as like putting a sun, or putting a strip of LEDs up here, or lights that show straight down, and they produce a shadow. Shadow, or mathematicians like to say projections. You'll hear that word a lot in math. If you take some of this, and you probably have already heard that. If y'all heard that before, the math people talk about that. Now, if I turn around and say to myself, okay, this is great, that's a projection, but I would like to have some lights project this thing back over to here. Okay, so the thing is that goes through an angle of, 70, okay. So if you project it back there, you got A, this time I've already used C, so I guess I'll use D, and A, the cosine of the angle between A and D. And lo and behold, this one will become the J vector. So its length is 1. This is still length 10. Let's go sine 70, which, by the way, is the same thing as sine 20. So, and I really don't know why things or anything is taught the way it is. I don't understand anything anymore. The more I learn, the more I don't understand anything. So, I mean, especially watching my daughter go through, watch the way it's taught, I'm like, okay, you're actually teaching you're going down an avenue, but you're going to have to come all the way back up, just go back here and go down this other avenue. Instead, if you would have introduced it in a different way, she'd have saved so much effort going down this alleyway and coming back and going over here. Education is like some sort of chaotic, just pathways of go and return and go and return. Okay, I can build on this, I have to turn back here. It's just, I don't understand anything anymore. So, I'm not going to figure out anything except that, okay, this is the way. So here's your angle, what was it called? Opposite, adjacent. See, I've already forgot that. Opposite, what that, opposite and adjacent. So, and that's okay to be thinking that way. But eventually, you're going to have to think in the way of a dot product. Now, since I'm here and I'm with dot products, let's go ahead and let me finish this, add them together, leave this right here. Then I'm going to use this for something else in a second. So I'll look at the angle and I say, project that to here through 30 degrees, it's cosine. Project this to here, 20 degrees, it's cosine. And then to me, the other. So I just look over here and I say, oh, I'll replace it with sine 12, sine of 30. And you've seen all this before. And then if you want to say A plus B equal to, you add this, you know, and I don't really want to go through the monotony of typing this into the calculator, but this is what you would get. And then you get that. So there's all great, right? Now, if the guy, or the person who wrote the book, and the guy is actually, he lives in Lafayette, he wrote the book, he's done this for 40 years now. Done a pretty good job. There are actually 3 major statics, dynamics books out there, and his has a better following than others. You know, each one is a little bit different, depends on your style. His is more modularized, so that's the reason I use it. Out there he may say, what is the magnitude of the resultant? And that's going to be just the square root of this. So I'll say that's some value, I don't know. So I'll say it's this. So this squared plus this other one squared. And you've all seen that before. Then you can measure the angles from there. So we sort of did that. So since I'm here on the dot product, let me go ahead and take the dot product and run with it a little bit to introduce us to the next step, which is we add a third dimension. So does this all make sense so far? So when you see me doing things like that, sometimes, okay, we all have an opportunity to communicate with each other. Sometimes I say stuff, I don't know whether I'm communicating correctly, so it's up to you to kind of tell me if I'm not. And so sometimes you may see me do things like that, and you may say, okay, what is it that you're doing? And I can stop and tell you the way I'm thinking, so that might be some help. So let's do something else with this dot product. It doesn't have to be just those two, any 2 vectors. So let's say we had 2 vectors. Do you know, shoot, I erased them all, didn't I? Okay, A is equal to, okay, let me just, sorry about that. Cosine, I'm going through 20 plus 10 sine 20j, and B is equal to 12 cosine, I'm going through 30, and then sine of 30j. Now I'm going to do something interesting. You look at these 2 vectors. What's the angle between those 2 vectors? Okay, you already know that. You can see it. Now let me give you okay. If you didn't have it drawn this way, if you had it drawn this way, and we know what I'll do this right over here, but I'll say A is equal to 2i plus 3j, and B is equal to 4i plus 3j. So I've got 2 vectors here. Let's see, I'm going to try to do a decent job. Move out 2 and up 3, move out 4, and move up 3 as well. So I've got 2 vectors. Here's one, and here's the other. Got A, I got B. Can you look at that and tell me the angle between them? No, not right off. But the fact that you can here means I'm going to use this, but I'm going to get your help because I'm not good with the calculator. So if y'all could tell me these numbers, and so that I can go down this, because it doesn't work unless I have actually numbers here. So when y'all get these numbers, tell me, I'll just jot them all down and go on to the next step. guess I need to learn how to use the calculator. I'm not very good at that. I use computer programs, I don't. I'm ready.
9.4,
9.4,
3.4,
3.4,
10.4,
10.4,
6.
and 6. Oh, cool. Okay. All right. So we're going to do something weird here. I'm going to go back to this. And I'm not going to confine C to be the base vector. I'm going to say it's just some random vector. So if we've got two vectors, A and C, and I want to know the angle between them, it sits right there, doesn't it? So I can sit here, and I can find this magnitude. You know what? I called it A and B. You know what I'll do? I'm going to use this and go ahead and take it back to a B to match what I'm doing over there. So there's my B. Can you tell me the magnitude of A? That squared plus that squared and then the square root.
I found this on the web.
You're not supposed to listen to my lectures. Okay, so here's what she said. Here's what she found on the web. What is the square root of the squared plus b squared? And it has the equation. It says open page. And then it has a YouTube video. Anyway, what did you find out? 10 exactly? Oh, yeah, that makes perfect sense. Sometimes it escapes me. A way to check. Okay, sorry about that. That's like who's buried in Grants too? I don't know. I can't answer that question. I haven't dug it up yet. So, I can answer this question, 10, and I can answer that one, 12. I can answer this one, but I'm not supposed to right now. So is there another way to represent this? Do you know of another way to represent this left-hand side? And you've probably seen it before. One way to look at it is this. Let's say, which one should I use? Okay, so let's say this. Okay, so I'm going to take you through a thought process so that you can answer this question yourself without me just telling you the answer. Okay, so I got A and B, right? I'm going to try to do a better job of writing A and B. And I should have done it once because I spent the time, but it doesn't matter. So here's A, and here's B. But what I'm going to do is I'm going to break B into two components. I'm going to say A dotted with some other vector which I'll call, I'll just call BX. And this will be a BX. And BX will be what? It will be nothing more than the length of that. I'll say, well, what do you want to call it? I mean, I hate to call it BX again, but I'll say it's the length of BX dotted with the length of BX, which is a scalar, a number, times I. So that means you can take this out, whatever that number is. Okay, in this particular case, it's just 4. Take the 4 out, you dot it, and you're dotting A with I. So if you dot this, A with I, what do you think you get? Okay, so did you get the logic of what I was doing here? I'm just taking this number out, which actually in this case it becomes 4. And I'm dotting the vector, so I'm going to do this individually. I'm going to dot this one, And then I'm gonna dot this other one, which will be by. And then I'm gonna add them together. But what do you get here? If you dot that, you know, you have AX, so I'm gonna list it. I don't know what the angle is, but what you're gonna find is it's just gonna be the AXI plus, AYJ, which in this case is 2 and 3. Dotted with I. What does that look like? What is J dotted with I? Okay, so let's think about this. Yeah, I dot I is going to be I, the magnitude I, makes an I, cosine of the angle between them, 0. I dot J. Doesn't matter what these are. These are just two vectors. I, J, cosine 90. So that's going to just equal 1. It's going to equal 0. So in fact, if I dotted these two out, I've done it. Can I erase that and just do it in full? Would that be okay? Let me just do it in full. Here's what I mean. 2I plus 3J. I'm going to do the whole thing without components. Okay. 2I plus 3J. Hopefully that's a better dotted with. 4I 3J. Now that I know that, I can take this dotted with that. 2 times 4 I dot I plus, I'll do this one and that one. 2 times 3 I dot J. So I first did this one, then I did this one, then I'm going to do this one, plus 3 times 4 J dot I, and now I'm going to do this one, plus 3 times 3 J dot J. That's gone away, because, I'm sorry, whatever I did, but I did that backwards, didn't I?
Cosine of 90 is 0. Cosine of 0 is 1.
Okay. Okay, let's try that. There we go. Okay, you should have stopped me and said, "What are you doing?" That's your job. You should bring a gavel. Bang on, you didn't do it that way. If everybody brought a gavel and someone just hit it, you know, I don't turn around and say, "Who did that?" I just know somebody did it and I just fixed it. So, okay, so did I fix it? Am I okay now?
I think so.
So, yeah, so cosine 0. Cosine goes like this. Like that, so 0, 1. Oh, no, 1, 0. So what's the value of I dot J? 0. I dot I. So what you end up saying, oh, if I want to dot these two, it's just 2 times 4 plus 3 times 3, right? Is that right? So I just look here. That times that goes here. This times this, you can't dot those two. No, it gives you nothing. This times that, dot that, no, nothing. This times that dot, you know. I'm not writing the J dot J or I dot J, I dot I. So now I can just say 8 plus 9. Isn't that 9? Help me out here. Isn't that 17? Okay. All right. It's the small math and the big math that gets me. So am I making sense? And there's a rewind button if I'm not. But the key is, if I'm not, and I'm not making any sense to me, you need to stop me. If I'm not making sense to everybody, then I'm probably doing something wrong. So the rewind button won't help you on YouTube. Okay, now that we got there, we come back to the question. What's the angle between this? You know what this is already, so I'm doing this to check it. I'm not doing it to check it on that one. So, I'll go ahead and erase this, and erase this too. And go back to this. I'm gonna verify that this actually works. So now, A dot B is equal to magnitude of A, magnitude of B, cosine between A and B. Now I know that's 10, but I'm gonna verify. What's the dot product here? That times that, plus this times that. Does that make sense? Does it make sense what I'm doing? So, I'll just write it down. 9.4, and again, you can help me, because I need a lot of help, let me tell you. You just don't even know how much help I need. Okay, so 3.4 times 6, 9.4 times 10. If y'all can tell me the left-hand side, over here I got 10, and I got 12. And then I got cosine of this mysterious angle, which I already know the answer, but I'm not supposed to know the answer yet. So when y'all get those numbers, let me know. I'll sit and rest for a second. Cosine inverse, so the angle should be, take all that mess. I can multiply that out. I think it's 120. Okay, so there's the mass. What's that turn out to be? I'm going to take a break for a second while y'all give me the number. So I'm guessing maybe that's, I don't know what that would be. What is that? 90 something and 19? No, 20? 90 and 20? What was it?
10.04.
Wait, all of that is?
That's 100 new.
Oh, that's
Oh, you're talking about the angle. Okay. Okay, so the angle. Okay. All right. Sorry. You see, again, my brain is not connected correctly to my ears, and my mouth is not connected correctly to my brain. So this is why you have to help me. So it turns out, we're almost right. We probably dropped some digits somewhere. So in fact, we verified that, yeah, we already knew it was 10. We got an answer at 10. This leads us to believe that we can take any two vectors, anywhere. As long as I have the x, y coordinates, I can figure out the angle between them, no matter where it is. So let's take this case. So here, I did the A dot B, and I got 17 is equal to the magnitude of A, magnitude of B, cosine of the angle between A and B. And we'll see this materialize out into a structure that is very beneficial to us. It probably won't be at the end of this class, but maybe not next, today Wednesday. So maybe by Friday it'll materialize out. Okay, so what's the magnitude of A? 2 squared plus 3 squared square root. Magnitude of B plus 3 squared square root cosine of AB. So if I want to know the angle between A and B in this one, it's equal to the inverse cosine of this big, this just number 17 divided by, it's funny is that it's so easy, the bottom was easy over here, but the top is easier over here. I don't know that that really means much, but 2 squared plus 3 squared times 4 squared plus 3 squared. Now that won't be 10.5. What is that number? I mean, we don't have anything to tag it onto. I don't know the number. I just. But if I got a few minutes, I'm gonna do something really bizarre in a second. So tell me what that number is when you get it. And I'm going to try my best. I'm going to try to redraw. Okay, 2 and 4. 2, say 4. And both the others are 3. I got enough time to. So what'd y'all get?
I got 19.4. Yeah, 19 degrees.
19 degrees? Like 19, is it, how close is it? 19.44? Okay. Now I'm going to do something very, very bizarre. It may seem bizarre, but you'll be doing this a lot. And so I'm drawing this vector A and B. So now you know it's 19.44. So let's project A in that direction. Does that make sense? So let's tilt our heads, and then we're going to say it comes down here. So what is 19.44? I don't have time to talk to Mr. Span. So here's, okay, I got to put the cosine in front of it. What was the length of A? Shoot, I didn't figure that out. What was the length of A? What is that? Oh, square root of 13? Okay. So what's that number equal to? This is the projection. Okay, so I'm going to write it in math now. Projection of A in directional of B. I don't know what that word is. Let's say direction, but what is that number equal to? Because we're going to find it a funny way in a minute. What's that number equal to? 12, 13, 14, 10, 5, 6, 12. It's got to be less than 13. 3.4. Okay, now I'm going to do something really weird. Okay, so let's verify. I'm going to verify this number by mentally doing something very strange. It may seem strange, but it's not actually that strange because you'll be doing it a lot anyway. So now I just say, I just want a unit vector pointing, I can't spell much, so just listen to my words and you can spell it. Pointing in this, along, how about along B? So I got this B, right? So how do you find that? How would you find a unit vector? We'll call it unit, so it's a unit vector, points along B. Anybody have an idea? Exactly. Where's B? Okay, here's 4. Now, I'm going to get you to help me because I don't know what 4 squared plus 3 squared is. So did you get what he said? Okay, so first, let me back it up and write it symbolically because this is all in the book. The B vector divided by the magnitude of B. That will automatically give you a unit vector pointing in that direction. So let's do that. And I get you to help me. So when you do that, Tell me what those two numbers are. Is it really? What's this, what is that? Oh, John, what? It's a 3, 4, 5. Okay, never mind. Okay. I remember thinking that when I made it. Okay, so there's my unit vector. Let's try something really weird now. What would happen if I dotted the A with this unit vector? I'm hoping it works out. I got enough time to make it work out. If it doesn't, I'm leaving. Okay. So what do? Okay, so first I'm going to stack the U up on top of this. So here's my unit vector in V direction. 4/5 of I and 3/5 of J, is that right? Okay, so what is that? That times that. 4/5 times 2 plus 3/5, okay. 3/5 times 3. That's a number. I don't know what that number is, but guess what? Tell me, well, you tell me what the number is. I don't know.
Altogether?
Yeah, if I do all that. 17? Oh, never mind. Yeah. So what is it? What is it in numerical? Without it, divide by. It's 5.
17/5. Yeah, 17.
17 was.
No, it's 8 plus 9 fifths.
Yeah.
Wait, so.
17/5.
Okay, so what is that? I can't divide. What is that?
3.4.
3.4? Holy crap, that's what that is. So what did we show? Okay, we showed that if we want to find a projection onto any vector, no matter where it is in space, it doesn't matter. If I find the unit vector in that same direction and dot it, did I have to know the angle? No, I didn't have to know the angle. I just came back and dotted it. So what I did, this is called UB, so here. So what you'll be doing a lot, and I'll tell you why you're going to do it. Let's say there's a boat. I'm not a good drawer, so here's a boat. Oh gosh, here's a boat attached to the shoreline. Here, let me spend a little time making this 3D. I'm not, here, I got enough room. Okay, so here's a barge. I can draw a barge, a box barge, big box barge. Does that look kind of 3D-ish?
Yes.
Okay, and so then we put a coordinate system on it, x. Okay, so if I do x and y, which direction does z go? This way or that way? Positive, which way does the positive z go? Right hand runs it that way. So the right hand, you always have to use the right hand coordinate. So you take the x, cross it into the y, that's where the z goes. Isn't that weird? So you gotta make sure you do it. Only place I've ever seen that not be the case.
Is that way?
Is there that way?
But it goes into the board.
You do this.
What if it goes in?
There's my right hand.
Everybody should do it.
So, Y, X, C. That's how I was taught it.
Oh, well.
You're not wrong.
Okay. Oh, I'm sorry. So, okay, so if you do this, okay. So if you do this, X and Y, you take your hand and then you shove your finger in the, not your finger, your thumb in the C. So the reason being is I cross J is equal to K. We'll get the cross products, don't worry about that. But that's the way, the right hand thing is to stick your you know, this is okay as long as somebody's, it sounds weird. So, I don't know. I mean, that is a coordinate system, but I don't know.
Now we're doing some weird thing with that X and Y.
Oh, yeah, because now, guess what? It goes, the Z goes the other way. It makes you crazy, doesn't it? Don't be crazy. So, let's just get to the point. So, here you got a hook on the shore, and your line is connected to it. You got a tension in that line, right? But you want to know the direction of force. So that's the whole thing. You want to know, okay, so if I'm pulling or maybe there's a tractor here. Maybe there's somebody, here's a big tractor with some wheels, and this weird dude on top pulling the boat, you know? So you want to know what's happening. So what you want to do, oh, that's awful looking. That line is supposed to be parallel with that one. So here he is. Say he's 20 feet this way and 12 feet that way. So you locate that. And what you need to do is say this tension is, he's got a meter in there and it's 1,000 pounds. What's the direction? Just like you say, where's the lunchroom? You got to have a direction. Where's the lunchroom? I don't know. Well, somebody's pulling you to the lunchroom. There's the lunchroom. There you are. But which is the direction you're going? It's no longer I, J, and K. It's some sort of weird mix. So what you do, or what you're going to do soon, is you're going to draw this vector all the way out here, from here to here, and then you're going to do exactly that. You're going to take the unit direction along that, and that's going to be some vector B over its magnitude. Then if you want to know the force, what do you do with that? Multiply times 1,000, and that's going to be your force. And so this will start occurring as you go through it. And I'll be, you know, what I'll do is maybe next week I'll bounce to the book and sweep us through everything. But he doesn't cover dot products until after, in your mind, you really need it to know what's going on. So that's why I'm taking this time to go through the dot products. The dot products get deeper because there's 3 dimensionals that we're going to cover next time. And then you're looking at something really weird, and it makes you kind of queasy. So before you come, take a roller. I'm going to take my tea and my Pop-Tart.
So what would he go to? I like a half part some. From Peru.